Today I'm going to give you an overview of the Hazelcast platform. The technology started out in 2008 and was focused on high performance in-memory distributed caching, compute and messaging. Since then we have added more capabilities to address the needs of leading-edge enterprise customers. Hazelcast is an open source cloud-ready in-memory platform that helps you build and deploy applications that require very high throughput and low latency. It's a real-time intelligent applications platform that helps you unify real-time data streams with context derived from traditional data sources. That unification and subsequent enrichment of data results in the ability to acquire immediate valuable insights and business advantage, whether it's increased revenue, operational efficiency, or gaining competitive edge. The emphasis on intelligent applications identifies that these modern applications may have built-in business logic, automation, as well as the ability to handle huge amounts of data. The core platform consists of two components, a distributed in-memory data store and a real-time and batch stream processing engine. You can use the in-memory data store component for low latency enrichment for data that has limited context. This gives you the ability to add meaning, value, and subsequent real-time insights that would have been invisible without this capability. So this architecture is ideal for when you want to combine operational or reference data with streaming data, and having both capabilities integrated within one platform offers tight integration and minimizes network activity between the two, resulting in far greater performance than if you had separate components bolted together. Note that the stream processing element includes both batch and real-time stream processing. So our stream processing engine utilizes a pipeline API for computational flow, offering flexibility and direct manipulation for join, sorting, merge, and aggregation, and many other operations associated with enterprise-grade stream processing logic, like windowing, transformation, and filtering from a variety of distinct stream sources. In addition, we can also feed this data into ML models to perform inference and then integrate that data into a variety of downstream applications or sinks. All of this runs on a peer-to-peer clustering architecture based on Java and provides the additional benefits of fault tolerance and scalability. You can easily ingest data from a multitude of data sources in a variety of formats using our out-of-the-box connectors, whether it's from messaging systems, Kafka, IoT devices, databases, and messaging queues, for example. You then have access to in-memory data or stream processing capabilities. With Kafka, you can replay that stream repeatedly to reindex or reprocess the data in a different way, offering great flexibility in an event-driven architecture. Once you have manipulated your data, we provide a variety of native sync connectors like S3, Kinesis, JDBC, and JSON, to name a few, giving you the ability to push contextualized data to enterprise applications, analytics engines, databases, authoring applications, and much more. Alerting applications and much more. In addition, all streaming syncs by default support at least once processing guarantees, and some support exactly once. You can build microservices clients that need access to data using our APIs, and this architecture supports many different languages, whether it's Java, C#, Python, or Node.js, and we also provide the ability to query and update both streaming and in-memory data using NestSQL. The platforms provide support for a wide range of developers, making it easy to deploy Hazelcast into their environments and have a variety of applications written in different languages access the same Hazelcast platform. Our APIs interface with a variety of systems of records or reference data, enabling you to ingest and process the data extremely fast, be it with databases, data warehouses, or file systems, keeping both cache and backend data sources in sync with super fast application performance and zero downtime. So imagine an online shopping application where there may be several microservices for browsing products, adding and removing items from shopping carts, and checking out. For this to be effective and accurate, sophisticated orchestration and rollback may be required, as well as an aggregation or calculation to track the available to promise information, a synchronization of data between the in-memory cache and the back-end systems of records. Hazelcast provides the capability to ensure data in memory and the system of record match. So this is what the Hazelcast ecosystem looks like. It's Hazelcast in the middle and the supporting components around it. This coupling of an in-memory data store and an stream processing engine gives the ability to perform real-time streaming and batch processing within a single technology stack. It's a cloud-ready distributed in-memory platform that enables you to build distributed applications. We guarantee high throughput, low latency, high availability, vertical and horizontal scalability, reliability, and a comprehensive security model. In addition, the lightweight nature of our platform enables you to deploy on small devices, embed within your applications as another dependency, or deploy as a standalone cluster both on-premise or in the cloud. So let's look at a traditional stream processing architecture. So data streams tend to suffer from data sparsity. After all, they tend to be data related to a specific event. You typically enrich that data from your systems of record, and that gives you meaning and context. But your system of record brings latency and complexity in terms of network and storage overheads, as well as the ability to merge these two data sources together in a meaningful way. Hazelcast addresses this challenge by integrating these key components of a typical event-driven architecture so that the data resides in memory for each of the processing tasks, giving you immediate access to both types of data. We have performance benchmarks that prove that this architecture comprehensively outperforms other solutions that rely on separate components running together. We ran tests using the Nextmark benchmarking suite. The suite simulates an online auction with bids and a series of questions related to auction activity. We were able to achieve a landmark number of 1 billion events per second on only 720 CPUs. So we were interested in identifying the hardware characteristics of 1 million events per second initially. Aggregations were being run every 20 milliseconds, and we achieved 16 milliseconds latency at the 99th percentile on a C5 4x large instance running in AWS. The most complex query requiring the processing of several aggregations was used to benchmark a stream with a throughput of 1 billion events per second. We used a 500 millisecond tumbling window to represent realistic processing and achieved 26 millisecond latency at the 99th percentile on 45 nodes with a total of 720 virtual CPUs running in AWS. The graph also shows that we achieved near linear scale. In comparison, other technologies would need at least triple the number of cores to achieve the same results. So, what are the benefits to having compute and storage on the same platform? Well, you share a single consolidated management center to monitor stream, batch, and in-memory operations via a consolidated management center. You can perform SQL queries across both the data streams coming in and the in-memory data with the same query. You can reduce your application footprint by increasing your server's storage capacity utilizing high-density memory. We offer simplified data accesses with our API for data in motion and at rest. And easier machine learning inference and machine learning operations encourage more experimentation by making it easier to deploy machine learning models into production, make changes, and rerun jobs. And in addition, Hazelcast gives you extreme efficiency, so you get much more headroom to push the boundaries of what you may think is possible on your given hardware. So this is just a list of some, but not all, of the architectural patterns that can be deployed with Hazelcast. A digital integration hub gives you the opportunity to perform data processing in memory, such as indexing and aggregation to provide richer data to each of the applications. This is effectively a data layer that streamlines processing performance for each of the slower data sources, like a relational database management system, or from a more costly source like a mainframe. This is appealing to companies who want to build modern applications with new capabilities that integrate with their legacy systems. This architecture supports both a continuous flow of data from an IoT stream or batch data. If you have a large volume of data and want to process data from specific data points, you can read it one data point at a time. If you have on-demand analytics, Hazelcast is a good fit. So here we have data sources and publisher apps, message buses like Apache Kafka and Pulsar, subscriber apps that read from the message bus and then send data to data sinks. We have customers who have deployed Hazelcast using these architectures, like BNP Paribas. Payment processing, real-time offers, and personalized recommendations are common use cases that support this architecture. We give you the ability to run machine learning inference inside the stream process. A lot of machine learning isn't designed to be scaled out and multi-threaded efficiently, but our platform architecture can run multiple Python virtual machines from one pipeline and execute parallelized machine learning that also takes advantage of a multi-core architecture. Hazelcast gives you a significant performance advantage. Because of that advantage, the platform enables you to run many models in your production environment at the same time. Some of our testing has shown that if you deploy machine learning models in a separate cluster and integrate it with using a REST interface, the performance could be as slow as 5 operations per second compared to almost 100,000 on a single node running Hazelcast. So there's a stark difference when running machine learning inference within our pipeline API, as opposed to a separate call using the REST API. If you need to drastically improve your throughput, then when running machine learning models, then Hazelcast is a great fit. Some use cases that are typical are fraud detection, industrial operations optimization, distracted driver analysis, and predictive maintenance. So continuing with machine learning, It's easy to deploy Python into Hazelcast's pipeline API. You can see that the jobs are broken down into subtasks and are run on different nodes. In addition, you can simply deploy your Python code to a specified file system location where it will be automatically deployed to the node performing the machine learning scoring when you submit the job. Note that the Python virtual machines are managed by Hazelcast, and that benefit is that it frees up any of the unnecessary administrative overheads. So let's imagine an analytics system that focuses in on a specific subset of the data for any analytic process. An example would be a back office trade monitoring system, which only requires analysis of a specific group of stocks and not necessarily the entire market. This means you do not have to build a complete analytical system for a huge volume of real-time data, which would be very expensive and not cost-effective for certain divisions within a company. An on-demand analytics system gives teams a near real-time view of the day's trades with aggregations and summaries applied. Queries are run on demand and only the relevant data is indexed. Analysts can then perform critical risk and compliance activities in a cost-effective way. This looks like a batch system, but we can deliver it in minutes or seconds throughout the day versus only at the end of each day. So the data's coming in from Kafka, the data's trades coming in from the stock market. So we're storing all of the trades detail in memory, and it's only the data that's requested. Data's aggregated as it comes in so that it can be stored in a summary format and presented to the back office team. So they can see for every stock that they're following the direction of the last trade. So if there's a panic in the market, they can drill down to individual trades immediately as the data is still in memory. So some of the advantages. Aggregations can be run throughout the day at any time, ready in minutes or even seconds. Drill downs can be queried in milliseconds. One cluster can serve the data ingestion, caching, eventing, and stream processing coordination and resilience fault tolerance out of the box. You only need to process the data that you need when you need it. Rather than merging all of the data, you can focus on the relevant data for a specific period. And some example use cases: back office trade monitoring, 360-degree customer analysis. If you have microservices in Docker containers and deployed in Kubernetes pods, you can have Hazelcast running in a sidecar configuration. This means that storage will be local to the microservices, resulting in fast data access, but as the Hazelcast cluster is distributed, it still means that you can have global access to the data if need be. This is a great platform for microservices and creating the statefulness that microservices typically need. You can use Hazelcast to perform large-scale simulations. This diagram resembles a high-performance computation platform, with Hazelcast being central to all of the processing. Our cloud-native support encourages this type of workload in the cloud. If you want to go to the cloud, you have the flexibility and agility of scaling out with cloud instances. Our stream processing component can be used as the ingestion mechanism from the original data sources. You can read the data very quickly, perform complex processing where each node ingests and processes a subset of the data and merges to produce the final output, and then push the results or output to a sink or destination. If you imagine counterparty risk calculations, for example, where you need to perform heavy computations within a given SLA, factoring in the proposed additional workloads may identify the risk of not being able to provide critical information in preparations for the next day's trading. This would expose them to penalties and other challenges that may compromise their business. The journey to legacy modernization can be a daunting one. Migrating mainframe and legacy applications to distributed and cloud environments in a timely manner, whilst reducing technical debt and integrating systems that were previously impossible to connect with, is challenging. Providing a platform that offers greater business agility, fit, and value compounds the challenge further. We have added even more capabilities into the Hazelcast platform to assist with this journey, by enabling the extension of application features, by encapsulating data and functions and making them available as services via an API, giving you the ability to rehost application components on other infrastructure without having to modify code. Hazelcast stream processing and change data capture capabilities address this. Change data capture can pull data from a legacy database transaction logs and populate the cache, whilst maintaining an audit trail of events and providing incremental changes to other applications and services like Kafka event streaming. Clients utilizing microservices applications can then benefit from having a real-time view of event-based data as it happens, make changes, and then reflect those changes back to the origin of source using right-behind caching capabilities, subject to your needs concerning performance and consistency. To make our platform enterprise ready and mission critical, we had to adhere to some key architectural principles. It's cloud first. So we're available on AWS, Azure, and GCP, and you can replicate data to and from any combination, making it easy to manipulate data from a variety of cloud-ready business units. All that data can be encrypted, and we support private cloud environments utilizing Kubernetes, OpenShift, and VMware Tanzu, and provide elastic scaling, fast and reliable. The platform delivers real-time processing and maintains high throughput and low latency when scaling, while providing capabilities to support zero downtime, memory first. Our architecture supports a distributed memory architecture, and that's what people recognize us for. That's how we get great performance and high availability at the same time, whilst also providing the ability to persist to non-volatile storage when required, and simplified. We wanted you to be able to quickly deploy Hazelcast using familiar object-based APIs, give you the ability to run the platform alongside your applications, and integrate with automation software that could spin up a cluster as and when needed. In addition, we have a 15 megabyte jar. That's a very light footprint, and that gives you the portability to run on whatever platform you want. So how is Hazelcast different? How do we differentiate against the competition? Well, when we're compared to databases are typically used as a repository for data. While some databases support a distributed architecture, none of them support distributed compute. In addition, few databases are embeddable due to their typically large footprint. Hazelcast's jar file has a very small footprint, making it perfect for edge-to-cloud use cases. No databases currently have a built-in stream processing engine. And against other grids, when compared to other data grids, Hazelcast is unique with a stream processing engine. In addition, other grids have not been designed with a distributed architecture. Some are fast as single siloed machines, but when you add more servers, the latency increases and the management becomes even more onerous. Hazelcast is also cloud native, whereas several data grids do not provide that support. Stream processing engines. Many stream processing engines struggle to achieve high throughput for on-demand batch processing. In addition, many do not support embedded architectures. The Hazelcast platform has a very light footprint, ideal for edge processing. Hazelcast stands alone in its ability to provide native machine learning inference for C++, Java, and Python models. Our stream processing engine batches requests together, further reducing overheads to ensure the highest performance. So Hazelcast is an integrated in-memory storage and stream processing platform. Due to its very light footprint, it is deployable from tiny devices all the way to data centers and any cloud infrastructure, providing elastic scale on demand, utilizing OpenShift and Kubernetes orchestration. Using the Hazelcast Inference runner, you can deploy machine learning models written in Java, Python, and C++. When we talk about enablers, we can break these into three categories. So we maximize productivity by offering you object-based APIs that you'll be familiar with for Java, .NET, C#, Node.js, Python, and Go. Our SQL API broadens the scope to users who have familiarity with the industry standard language that want to interact with in-memory data. The embedded deployment option enables you to deploy Hazelcast alongside your application, removing the need for additional infrastructure and removing the need to serialize and incur network traffic. Being lightweight, Hazelcast can be deployed on the smallest devices all the way up to lakes. Near cache enables Delta data requests to be handled by the local node rather than incurring remote operational costs, like network and serialization, deserialization, thus improving query performance. OpenSSL is optimized to run fast and minimize performance degradation due to encryption overheads. Data pipelining provides an easy way to build data processing steps for tasks such as data transformation, enrichment, augmentation, filtering, grouping, aggregation, and running algorithms against the data. Cooperative multi-threading is used to maximize CPU utilization by minimizing context switching and preserve cache lines. Pipeline API-based optimization enables you to harmonize and optimize throughput by reducing computational overheads and optimizing memory utilization from other distributed data systems. WAN replication and automatic failover give you the ability to replicate to another site for local servicing via geographical distribution and disaster recovery. In the event of a site-wide failure, these two capabilities enable you to failover to another location and redirect clients to the failover site. Data replication protects your data by having a backup copy on a different member in your cluster that can be promoted if you suffer a hardware failure. Our security model encapsulates your whole environment in a comprehensive enterprise-grade security suite, offering 3 levels of security. Privacy, which includes TLS and SSL encryption, authorization, which is all about role-based security, and offer an authentication if you want to integrate with LDAP, Kerberos, and Active Directory. All businesses should consider moving to cloud, but a simple migration is often not sufficient. To get the biggest gains from the cloud, you should look to a path to offload the administrative overheads to a managed service. We have a team of Hazelcast specialists, some of whom worked in the engineering teams who manage the infrastructure for you, whether you need to elastically scale, require enterprise, industry-grade comprehensive security, or replicate data to other locations, persistence, and off-heap storage, for example. We support all the languages available to our on-prem versions, and code changes will be managed by Hazelcast. We then focused on providing a service that would enable you to integrate different parts of your business that may be hosted on different cloud providers and on-premise. So we support both hybrid and multi-cloud. You can pull data from any data source using our cloud connectors, canonicalize your data, and push to any destination. Think of edge-to-cloud use cases where you may want to pull data from smart meters, mobile devices, and legacy factory machines, merge the data, perform analytics against it, and then push that to another service for valuable insights or even more analysis. Hazelcast Cloud provides several topologies for providing high availability and disaster recovery. Top left, you can host your cluster in a multi-zone environment. This prevents data loss should one of your availability zones fail. Top right, offers you both business continuity and speed. You can work with your nearest cluster instance and divert to another location should the local become unavailable. Bottom left, this multi-cloud topology can protect you from widespread outages affecting the provider's entire infrastructure, or allow you to deploy in a multi-cloud fashion to meet corporate requirements to avoid lock-in to a single cloud vendor. And bottom right, enables you to combine private, public, and on-premise resources, offering greater flexibility for workload deployment and the potential for competitive advantages. So Hazelcast has achieved multiple certifications for our cloud offerings. So PCI DSS is a security standard for organizations that handle credit cards. SOC is a system of service organization controls. These controls go beyond just software certification and cover many aspects of how the provider organization is run. So SOC 1 covers financial reporting, SOC 2 covers operation procedures including organizational oversight, vendor management, risk management, and regulatory oversight. SOC 2 Type 1 reports over a specific moment in time, and SOC 2 Type 2 reports cover an evaluation period of not less than 6 months. HIPAA regulations are privacy regulations covering companies that deal with healthcare information. So specific rules covering privacy, i.e. who can access, and standards for storage and transmission. That concludes our overview on the Hazelcast platform. We are happy to drill down on the details as required.